Hi, I'm Papia. In this problem, we have a function 2x cubed plus x squared minus 5x plus 2. And two factors are given to us. One is x plus 2 and one is x minus 1. We have to verify these factors for f of x, that if these are factors of f of x. Then we have to figure out the remaining factors of this function. And then we have to find the complete factorization of the function, list all the zeros. And finally, we have to confirm our result using a graphing utility. Okay, so let's start by verifying the factors of f of x. Well, we can use synthetic division and easily verify. So let's write down the coefficients of the function. So we have 2 for x cubed, 1 for x squared, negative 5 for x, and 2 for the constant term. Now we want to verify if x plus 2 is a factor, which means we want to verify if negative 2 is actually a 0. So you have to use negative 2, not positive 2, because when we have x plus 2, we want to rewrite it as x minus of minus 2. Okay, and we want to write it as x minus c, if c has to be a 0. All right, so let's check if this is a factor, which means if negative 2 is a 0. So this is synthetic division. You bring down 2. 2 times negative 2 is negative 4. Add negative 4 and 1, you get negative 3. Okay, negative 3 times negative 2, that's 6. 6 minus 5 is 1. Negative 2 times 1 is negative 2, which adds to 2 to give you 0. So remainder 0 means, by remainder theorem, that f of negative 2 is the remainder, is 0, which means negative 2 is a 0 of the function, which means that yes, x minus of minus 2, which is x plus 2, is a factor. Okay, so the first one is checked. Now we have to check what about x minus 1. Now you can use the same method again and check with the number 1 here, but instead of doing that, we can also do something simpler. We can only consider these three numbers. They are the coefficients of the quotient, and check if x minus 1 is a factor of this remaining polynomial. If that's the case, then it will also be a factor of the original one. So we can just take 2, negative 3, 1 and check if x minus 1 is a factor or not. So write down 1 here and use synthetic division again. So you bring down 2. 2 times 1 is 2. 2 minus 3, negative 1. Negative 1 times 1 is negative 1. Negative 1 plus 1 is 0. So yes, since we get remainder 0, that means x minus 1 is also a factor. All right, so for part A, we verified the two factors. Now we have to find the remaining factors of the function, and we can do that very easily from this final answer here. Note that these are the coefficients of the remaining factor. Okay, so the remaining factor will be, this is the constant term, this is the coefficient for x. So the remaining factor is 2x minus 1. Well, look, this is a linear already. X has a power 1, and so we don't have to factor it any further. It's already factored. So this is the last factor of this function f. So what is the complete factorization of the function? Well, let's see. We have the two factors that were given to us, which we verified. One is x plus 2, one is x minus 1, and the last one we found in part B, that's 2x minus 1. So this is a complete factorization of this function. Okay, let's move on. Now we want to list all the zeros of the function. And you know, each factor will give us a 0. So from x plus 2, we'll get, when is x plus 2 equals 0? When x is negative 2. From x minus 1, when is it equal to 0? When x is 1. And finally, when is 2x minus 1 equals 0? When x is 1/2. So our zeros are negative 2, 1, and 1/2. We got all the zeros of the function. All right, finally, we have to confirm our results using a graphing utility. So you can take a graphing utility. You can write down the function that's given to us, 2x cubed plus x squared minus 5x plus 2. And you see the graph, and you can see that the function does cross x-axis at 3 places. So it has 3 zeros. To check these values, you can use trace and write down x equals negative 2, and you get 1, 0. X equals 1 gives you the second one. Well, x equals 1 gives you the third one. X equals 1/2 gives you the second one. So from the graphing utility, it verifies that we have done everything correctly. That completes the problem. Thank you.